Okay,
Sam, that's not Sam.
question 17. Yeah, that was actually. A tire manufacturer sells tires in packages of 4. The tires are shrink wrapped together without covering the hole in the center. Determine the amount of shrink wrap required for each package in square centimeters. Oh, wow. Okay, so let's try to get an idea of the shape they're giving us. I don't know if I'll be able to do it with this. We have our tires here.
Those all look like tires.
Actually, hey, I'm not done yet.
Are you sure?
You guys are very... There we go.
So it just looks the same. Now you're getting farther away from the glasses, sir. Cool. Those are donuts.
There we go.
So just copy and paste the car.
Oh, this is all right.
Oh, it worked pretty well. I thought you said it was a tire, sir. That's a race car tire.
Okay, and
Sir, can't you copy and paste the whole
really, okay, so we've created our tire, and we're gonna go through the measurements of this tire. We'll do them in red here. So from here to here was 111 millimeters. The height of the tire was 185 millimeters. And the diameter, because this is a circular object, of the tire was 57.76 centimeters. Okay. Now, what's important about this question is they've asked us to shrink wrap it. And what that means is they're talking about the surface area of this tire. They said that the shrink wrap goes inside of it and it doesn't cover the hole. So it goes in and wraps around the tire. So what that means is we need to find the surface area of this face of the tire. Is that going to show up?
No.
Oh, kind of. We need to find the surface area of the outside of the tire.
Oh, there it goes.
We need to find the surface area of... Okay, we need to find the surface area of the top and the bottom of the tire, because there's going to be 2 parts of that. Oh, what have I done?
Oh, there it is. Pick that button, sir. It's like the...
And finally, we're going to have to find the actual surface area of the inside face of the tire. Okay? So there's quite a few objects we need to find surface area. First thing we're going to work with is we're going to work with finding the surface area of this outside face, the large object. Okay? And in order to do that, we have to think of it like a very large rectangle that's been wrapped around a circle. Really, that shape is something like this, and it's been wrapped around our circle to get all the way around the face. Okay? So, since it's set up like that, what we need to find the area of this rectangular object that wraps around the circle. So, we already have the height of this object. We know that it's 185 millimeters, not meters.
Oh,
So we have the height of the tire. We know that the height is 185 millimeters. But we need to find the length of this tire. And in order to do that, I actually have to find the circumference of this circle. The circumference of the circle on top, the outside part of it, will be the length of this rectangle. So in order to find circumference, we're going to write down our formula. Our formula for circumference is C is equal to, anyone? Pi times your diameter. Okay? So, we already have the diameter of this circle, but the only problem is the diameter of this circle is measured in centimeters, and we need to convert it to millimeters. So we're going to write down our conversion rate. 1 centimeter is equal to 10 millimeters. Okay? And since we have 57.76 centimeters, we have to figure out how many millimeters that's going to be. Yesterday I set this up as a fraction for you guys. A couple of you guys figured out that, in fact, all you really need to do is divide this amount by the conversion rate. So if we divide 57.76, sorry, other way around. If we multiply 57.76 by 10, we'll get it. So I'll set it up like a fraction ratio again, just so you guys can see it. We have a centimeter is equal to 10 millimeters. So we have 57.7 centimeters. I'm writing that in the wrong spot.
Really weird.
57.76 centimeters. We have to figure out how many millimeters that's going to equal. We want to convert this so that we're working with the same measurement the whole time. Okay? So I actually have to get x on top. Right now I've drawn x on the bottom of the fraction, but we can rearrange this. Just like our sine ratio from last chapter, I can actually flip this. I'm going to turn it around so that the x is on top, and our other numbers are on the bottom. That way it's easier to rearrange. As long as the bottoms stay equal to each other and the tops stay equal to each other, we can rearrange which numbers are on top and which are on the bottom. So, all we have to do is isolate for x. So we're going to bring our 10 over. We know that 57.76 divided by 1 is just the same number. So 10 times 57.76 will give us our x. So we're working with 577.6 millimeters as the diameter of this circle. So our diameter in millimeters is 577.6 millimeters. We're going to plug that into our circumference formula. C is equal to pi times 577.6. We're going to type that in the calculator. 577.6 times pi equals 1814.5. So the circumference is 1814.5 millimeters. So what that we just figured out there has given us the length of the rectangle. So our length of this rectangle is 1814.5 millimeters. I can now find the area of that face. The area of a rectangle is base times height, or length times width, whichever way you guys are used to writing it. So the area of our rectangular face is our base times our height. We just solved that the base is 1814.5. And the height was 185. So the area of our rectangle, we'll multiply those two numbers together. No, the R is just telling us that it's a rectangle. A stands for area. I put subscript R so we know that we're talking about the rectangle.
So it's AR.
Is area of a rectangle, yeah. 335,698. 335,698 millimeters squared. Okay? So, we've only found one part of this. We found the face on the outside. The next thing we need to do is we need to find the areas of this black area right here, the 111 millimeters. And what we're going to do to solve that is we're actually going to find the area of the larger circle, which we just solved the circumference for. And then we're going to find the circumference of the smaller circle, and we're going to subtract the two of them. When we subtract the two of them, we'll be able to figure out the area of the top and bottom of the tire. Okay, so we've set up the top of that circle again on another page. And what I'm going to do first of all is I'm going to find the area of the larger circle. And when I get that area, I'm going to subtract the area of the inside, the smaller circle. So in order to find the area of a larger circle, area of a circle is equal to, anyone? Pi r squared. Good. So we need the radius from the middle to an outside. Half of the diameter. We know that our diameter is 577.6, so diameter is equal to 2 times r. That's our equation for diameter related to radius of a circle. We're going to plug in 577.6 for the diameter. We have that here. Is equal to 2r. And we're going to isolate r. So in order to isolate r, I have to bring 2 to the other side, which means I'd have to divide both of them by 2. So what ends up happening is we get 577.6 divided by 2, 288.8. So the radius of the larger circle is 288.8. It's equal to r. So we take that formula we had above, and we're going to find the area of the larger circle. Area of the circle was equal to pi. Our r is 288.8 millimeters squared. So we're going to plug that into the calculator. We square that amount, and then we multiply it by pi. We end up with 262,025. 262,025 millimeters squared. So that's the area of the larger circle. Next, I have to find the area of the smaller circle. So, in order to find the diameter of the inside circle, I'm actually going to have to subtract this amount, 111, which is this distance. I'm going to have to do it twice, because it actually takes up 2 parts of our entire diameter. So we take this number, 577.6, and we're going to subtract 111 twice. Jordan said it was 222. He added them both together in his head. So, to find the diameter of the smaller circle, we take, we'll call this diameter of the other circle, is equal to 577.6, subtract 111, subtract 111, which is the same as subtracting 222. We take those numbers, 577.6, subtract 222, that's 111 twice, 355.6. So the diameter of our smaller circle is 355.6. Can I just put that into an area formula now? Good. So we figured out that the diameter of the smaller circle was 355.6, but we need the radius, which is half that amount. So we're going to take that number, 355.6,
Is that your phone, sir?
divided by 2.
Way to pull it off, sir. I'll go.
177.8
Is that the unit?
millimeters. So the radius of our smaller circle is 177.8 millimeters. We're going to plug that into an area formula now. So area of the second circle is pi times the radius is 177. We just figured that out. 0.8 squared. We'll plug that into the calculator. We square that amount, then multiply it by pi. We get 99314. 99314 millimeters squared. So We're doing all right so far. We found two areas. What we need to do to find the area we're looking for, or total area, is we need to take the area of the first circle, so I'm going to put a little 1, area of the first circle, and subtract the area of the second circle. So this was our second circle's area, and the first circle's area we found up here. So we need to take this number 262,025, 262,025, and then we just subtract our new area of the smaller circle, 99,314. We'll take those two numbers, 262,025, subtract 99314. 162,711. So we get 162,711, also known as 162,711 millimeters squared. Have I found the area of both the top and the bottom parts of that circle? What do I have to do, Sampras? Okay. Since we only found the area of the top part and the bottom part will be identical, we just have to multiply our number we got at the bottom by 2 in order to find the top and bottom. So area of top and bottom is going to be this number multiplied by 2. $325,422. Millimeters squared. Okay, and finally, the last thing we need to do is the inner face of the smaller circle. Remember we found the rectangle of the outside of the circle before? We have to find the rectangle on the inner part of the circle. So in other words, that smaller circle, we're going to take it to the outside. Underneath it, inside of it is a small rectangle. We know the height of it because it's still the same height of the tire. It's 185 millimeters. But the length of this one will be a little different. In our previous question, we discovered that the diameter of the inside circle was 355.6. So we're going to use that information. The diameter of this smaller circle was 355.6 millimeters. Remember, I need to find the circumference of it in order to find the base or length of this rectangle. So, circumference again was d times pi. Our diameter was 355.6 multiplied by pi. So, 355.6 times pi equals 1117 millimeters. So finally, the area of the smaller rectangle inside will be our base times our height. 185 times 117. 206645. 206645 millimeters squared. So, what we've discovered are the surface areas of all parts of one tire. Even though this question asks for 4 tires, we're not going to get into it. I'm happy if you were able to find the area of all surface area of this entire tire on the inside. So, the final step, I would technically need to add up for total surface area. I would have to add up the area of the rectangle on the outside plus the area of the rectangle on the inside. We'll call them 1 and 2. Plus the area of the circular object on top. That was area 1. Plus area of the circular object on the bottom. We'd have to add all of those up in order to get our total surface area. So we're going to take that information. We've actually solved for all of those. All right, area of the first rectangle is 335, 698 plus 206, 645. And the areas of the two circles that we had, area of the first one was 262,025. 262,025. And the area of the last circle we had, 99,314. Give me 1 second.
Sir, is this going to be on the test? You just said no.
Anything I teach you could be on a test.
That's a very broad answer. Please note.
We're going to add these numbers together.
Good talk. Better figure out how to make one.
And finally, 903, 682. 682 millimeters squared is the surface area. We are amazing.